Hi everyone, welcome back to Lulumath. This video is on expanding polynomial expressions, but this time we're going to be using a geometric model or the box method. If you prefer FOIL, that video is available on our website and at the YouTube channel as well. One of the benefits of the geometric model or the box method is that it's really good for you if you are a visual person. So if you need to see things written out visually for you, this is a great method. It's also really nice because you can expand it to more than just a binomial multiplied by a binomial, okay? With FOIL, you can only use it for a binomial multiplied by a binomial. So you need to have some background knowledge. You need to know some things before you can do any type of expanding of polynomial expressions. So the first thing you need to know is how to multiply monomials by monomials. And if you need a refresher on that, please make sure to check out that video. And you also need to know how to multiply monomials by polynomials or use the distributive property for that. And again, if you need a refresher, please make sure to check that video out as well. So before we actually expand the question that we see right here, I just want to talk really quickly about what multiplication even means. So if you were given a question where you are asked to multiply 2 times 3, essentially what you're doing is you're just trying to find the area of something that is 2 units by 3 units. So if I have something that is 2 units by 3 units right here, see how we have 2 units on the left side up over here, and then on the bottom right here, we have 3 units right here. So altogether, we have 6 square units. So the reason why 2 times 3 is equal to 6 is because we have 6 square units. So what does that mean? Well, why are we even talking about this basic concept? Well, if you were to take that concept and apply it to algebra, it makes the algebra a lot easier. So if you notice here, this is a binomial, so it's a 2 terms by another binomial, so another 2 terms. So we could make this right here into a 2 by 2 geometric model. So if you notice, our first binomial says x minus 5 right here, okay? So I can put x minus 5 either on the top or on the side. It's totally up to you. I'm going to choose arbitrarily, randomly to put it on the top. So because there are 2 terms here, my first term is x, so I'm going to put an x in my first box. My second term is a negative 5, so I'm going to put negative 5 in my second box, okay? Then I have a second binomial that is x plus 7. And since I put this x minus 5 on top right here, I'm going to put this x plus 7 on the side over here. So this is x, is my first term right here, and my second term is a 7. Well, I want to figure out what the areas are going to be. So in my first box that I have right here, I'm going to multiply this x by this x. So that means that I have a side length of x and another side length of x. So this ends up being x times x, which is x squared, okay? Then in my second box that I have here, this is a side length right here of this x and another side length right here of this negative 5. So this is x multiplied by negative 5, which we simplify to negative 5x. All right. In our next box that we have right here, I'm going to have a side length here of this 7 and a side length here of this x. So this ends up being 7 times x, which is just simply 7x. And then in our last box that we have right here, we have a side length of 7 here, and it's being multiplied by this side length of negative 5. So this is 7 times negative 5, which is negative 35. A quick note that the multiplication that I'm writing out up here, you don't have to write out every single time. I'm just showing you where these values are coming from. So now I just need to collect my like terms. Well, I have this x squared here, and there's nothing else like the x squared. So I'm simply just going to write down x squared. Then I have this negative 5x here, and the negative 5x is like the 7x. So I'm going to put the negative 5x and the 7x together. So negative 5 plus 7 is positive 2. And then there's x's here. So this is going to say plus 2x. And then I have this minus 35 right here. There's nothing like it, so I'm just going to write it down as minus 35. And this is what I get when I expand x minus 5 by x plus 7. Let's take a look at our next example that we have here. We've got 2x squared minus 9, and that's being multiplied by x plus 8. So again, we have a binomial multiplied by a binomial. So I'm going to create a 2 by 2 box again. So my first binomial is 2x squared minus 9. This time I'm going to put it on the left side so you can see it doesn't matter which side you put it on because it doesn't matter what order you do multiplication in, it's always commutative. So my first term was 2x squared right here. So I'm going to put 2x squared in my first box. And then my second term is negative 9. So I'm going to put minus 9 right here in my second box. Then I also have this x plus 8 right here, so I'm going to put that on top over here. So my first term is x, so I'll put an x right here, and my second term is an 8, so I'll put an 8 right there. Now I need to go ahead and do my multiplication. So in my first box, I'm going to multiply this side length of 2x squared by this side length of x to the power of 1. This time, I am not going to write out the 2x squared times the x. I'm just going to go ahead and simply do the multiplication. So 2 times an invisible 1 is 2, and x to the power of 2 multiplied by x to the power of 1 is x to the power of 3 because 2 plus 1 is 3. In my next box here, I'm going to multiply a side length of 2x squared right here by a side length of this 8 right here. Well, 2 times 8 is 16, and then I just have an x squared right here, okay? In my third box that I have here, I'm going to multiply a side length of negative 9, which we got from this negative 9 here, multiplied by a side length of 1x. So negative 9 times 1 is negative 9, and then I just have an x left over, okay? And then lastly, in our last box that we have here, I'm going to multiply a side length of negative 9 right here by a side length of 8 right here. So negative 9 times 8 is negative 72. All right, now let's go ahead and collect our like terms or put together our like terms and then we'll be done. 2x to the power of 3, nothing else has an x to the power of 3, so I'm just going to write that down. Okay, then I have 16x squared right here, and nothing else has an x squared on it, so I'm going to write that down. It's positive, so I will write plus 16x squared. Then I have this minus 9x, and nothing else is like it, so I'm going to copy that down. And then lastly, I have this minus 72 and nothing is like that. So I'm going to copy that down as well. So this is my final answer when I expand. All right, in our last example, we're asked to expand the quantity 3x minus 1, all of it squared. So I just want to talk about a common mistake that people tend to make first before we go ahead and talk about how to actually find the correct answer. So a lot of people will say, oh, well, I see the squared on the outside. I'm just going to square each term on the inside. So 3 squared is 9, x squared is x squared, and then negative 1 squared is positive 1. And this right here is incorrect. So what I want to do is graph out a parabola that would say y equals 3x, the quantity 3x minus 1 squared. And I want to graph out y equals 9x squared plus 1. And if these two expressions were equivalent to each other, this one and this one, then our graphs would look identical. So let's go ahead and do that. Y equals, I'm going to put in brackets 3x minus 1, close my brackets, and then I'm going to square it. And then for the other answer that we got, was 9x squared plus 1. And if you notice, we have our red parabola, which is our top one up here, and we have our blue parabola, which is our bottom one down here. They don't line up, which means that our expressions here are not equivalent. It's a very common mistake people will make. Don't fall into that trap. With that being said, we need to understand what 3x minus 1 squared means. Well, 3x minus 1 squared means you need to multiply it by itself. So it's 3x minus 1 multiplied by all of this 3x minus 1. So this ends up being another 2 by 2. So if I take a look right here and do this multiplication, I can just write 3x and -1 is my first binomial, and then I can put 3x and -1 as my second binomial. Notice how this ends up being a square when we do this, and this says 3x minus 1 squared. That is not a coincidence. So let's go ahead and do this multiplication. So in my first box that we see here, I will multiply 3x to the power of 1 by 3x to the power of 1. So 3 times 3 is 9, and x to the power of 1 times x to the power of 1 is x to the power of 2, or x squared. In my second box that I have here, I have a side length of 3x by a side length of -1. So this is 3x, this is -1. So when I do that multiplication, I end up getting -3x. In my next box here, I'm going to multiply a side length of -1 by a side length of 3x. So -1 multiplied by 3x is -3x. And then in my last box, I'm going to multiply a side length of -1 by a side length of -1, and -1 times -1 is +1. Okay, now I'm just going to collect my like terms and then I'll be all set with this question. So this 9x squared, nothing else is like it. There are no other x squared terms, so I will copy that down. This -3x is like this -3x. They're both negative, so they don't cancel each other out. They just become even more negative, so I end up getting -6x. And then this +1, there's nothing else like it, so we can just write +1. And this is the final answer. Again, the advantage of this method is that you can use it for any type of expansion that you would like to do. So I can expand, for example, 5x minus 7 multiplied by 2x squared plus 8x minus 1. And if I wanted to do that, this would end up being a binomial, so a two terms by a trinomial. So the only difference is now it would be a 2 by 3 box instead of a 2 by 2 box. If you want more information on that, make sure you check that video out. Thank you for watching. If you have any questions, please comment below or reach out at lulumath.com, where you can also find blank or completed notes from this video. If this video was useful to you, please don't forget to subscribe for more videos and share with others. See you next time.